Well, good afternoon to all. My name is Ismael Vasquez. I'm the Technical Sales Manager for GCT and Carmelo. And today we'll be speaking about the introduction of the structural concrete insulated panels. And I don't know if Scott is with us today, this afternoon. Scott is our sales and tech in Florida. So yeah, we're going to give a short introduction of what's the structural concrete insulated panels. We'll go component by component and describe those, what applicable codes for, let's say, building codes for the U.S. and also Puerto Rico it complies with, what thermal characteristics these panels have, which is a very, very good bonus there, to do the construction. Also, if we have time, we'll go over from the foundation all the way up to the, let's say, finishing the project. And also we'll be discussing several projects that we have done in the U.S., Puerto Rico, and also around the world with these SCIP systems. And then at the end, we'll collect all the questions and make sure they're all answered. So what we're going to be speaking today is structural insulated building component or structural concrete insulated panels. These were developed in Italy back more than, let's say, 40 years ago. And we have been using it widely in structures in the U.S., Puerto Rico, Caribbean. We also did some testings where we also qualified the Florida product approval, and we can also get permits with the government agencies for construction, also for use of these buildings. So it allows, let's say, for design for hurricane and seismics. So it can withstand, let's say, 165 miles per hour to 280 miles per hour, depending on the size of these panels or the thickness. And it has a high insulation R value that goes from 12 to, let's say, 36. So your building will be more energy efficient as well, and we have used these in residential, commercial, and industrial all around the states and in Puerto Rico. So we have two types of PSM and with GCT, which is Gulf Concrete Technology. We're located in Mississippi, and that's where we manufacture the panels. The PSM can, I think, James, if you can put or somebody in mute. I'm hearing some noises out there. And if you can, these PSM panels, they're expanded polystyrene, which is the core, the center, and then on each side it'll have galvanized high strength steel, which won't corrode, all right? And those are electrically welded to the surface of this foam or EPS on each side, if it's the wall, and also you can use these panels on in between floors and on the roof as well. So the PSM, going to the description, right? It has the foam, the steel, and then you will cover it with a structural mortar, which has to be about 4,000 psi, and that has to be 3/4 inch over the steel mesh on each side, okay, of this panel. So the PSM usually are used for walls, and up to, let's say, if you have walls have a in between area, let's say up to 12 feet in between walls, then you can use these PSMs. So, but if it's over 12 feet up to 32 feet, you can use the PSGs, which has a T-beam pocket in the center, and that's where you place 2 half-inch rebars, and you fill it up with the concrete on the top. And so now you can do, let's say, spans up to, let's say, 32 feet, okay, with that PSG panel. So the PSM mostly are used on walls, and some roofs up to 12 feet, and when you have spans up to 12 feet, and PSGs are used mainly in between floors, or let's say on the rooftop. So just to give you a little bit of details of the wire we use, is it's a high tensile strength, high galvanized, right? 95 KSI, right? And also it has two types of strand. One on the vertical side, which is the principal direction, right? It has 3 millimeters there, or let's say 11 gauge. That's where all your strength is right there. And we also have some crosshairs of which is 2.5 millimeters, or we say 12.5 gauge. That's your secondary steel. Okay, and then what other reinforcement do we need, right? It all depends on what the structural engineer is looking, or the architect is looking at, right? They can do additional reinforcement, but mainly these systems were tested with just anchoring to the base of the foundation or floor using a 3/8 of an inch rebar, and those would be drilled in like 7 inches, and there it'll be over the surface of the floor about 18 inches, and then they're spaced out like every 16 inches, and you'll have 2 rows staggered on. So that's where you place the panel. A little bit on the mortar we use. We in our company GCT we make structural mortars in our plant, and we do require it has to have at least 4,000 psi. If you use another brand or regular concrete, it has to be 4,000 psi. And we also use a machine called the Monomix. This machine mainly pumps out in low volume, where you can, let's say, put the bag on the hopper on the top, and it'll mix it with water, and it has a line about 32 feet, like 25 millimeters or 1 inch diameter, and then we'll shoot it with it has where you can spray the structural mortar on the walls or on the ceiling as well. So with this machine, so and then on the top on the top of the let's say of the slab, let's say in between slabs or on the roof, you may specify, let's say, 3,500 psi concrete from your local ready-mix producer, which will have, let's say, minimum slump 2 inches. That's real low, but if you have a lot of high pitch roof, then it'll be 3, 4, depending on the design of the mix. And then the maximum aggregate you should have is 1/2 inch or less. So it has to be 1/2 inch or less. So it gets in between, the meshes and the foam as well. So that's all we require there for the concrete on let's say over the slab or over the panel, and also on your foundation will be also regular concrete at 3,500 psi, 4,000 psi. All depends on what the structural engineer is designing there for your foundation. So we have prepared with DRJ, a certification, a manual where we have all the properties of these panels, and here you can see the sizes with the PSM 60 means millimeters, but and PSM 80 is 80 millimeters. So in between wires, from wire to wire, it'll have, let's say, 4 inches. So when you apply, let's say, mortar on each side of that panel, it'll end up like 5.5 inches to 6 inches. Okay. So, and then depending on the R value that you want, also on the size of that wall for the PSMs, then you can choose, let's say, 100, 120, 140, and then you can see the sizes up to a 240, which is from wire to wire about 10.5 inches, and then it'll finish with a slab about 12 inches. That's real big. Here on the right, here's the self-weight of the panel would be like 35 pounds per square feet. That's with the foam and also the concrete. So what type of spans can we do with let's say, a PSM 80? That's one of the panels that we use in our areas a lot, and you can use that up to 10 feet, and you can get up to, let's say, 50 pounds per square foot, right, of load there, with your live load, dead load. So you can get up to 50 pounds up to 10 feet. So if you have your in between spaces up to 12 feet, let's say, then you can't use that panel. So you go in your chart here all the way down, let's say probably 35 pounds. It's something that you can use. So you'd be on a PSM 120 or over, okay? So you can use 120 to 240. But then if you're going to want you have your walls, in between walls is over 12 feet, then you have to use a PSG. So these are the PSGs, and they have a small girder, let's say, probably be like 4 inch by 5 inches. And this is where we put, let's say, two rebar, two number twos there, making sure that you have chairs there, it's not sitting on the foam, okay? And so these comes in two open girders, 3 and 6. So depending on the let's say the length you have in between of these in between, let's say walls or shear walls or you don't want any beams in between those. So that's how much the length you're going to be wanting to go. Let's say let's say you want to go to 20 feet. So these are the type of panels you'll be using for those types of lengths. So and again, on the top, we're going to be pouring 2 inches minimum of concrete, okay? And in every, let's say if you have a slopey roof, all right, then it'll be 2 inches on the bottom and 2 inches in the middle and then 2 inches on the top. That'll be your thickness of that concrete over the steel mesh, okay? But if you have a flat roof, then you have to use every foot, you have to go up a 1/4 inch. So probably in the center of your building, it'll have like 5 inches. Now at the end, or it'll be like 2 inches of concrete over the mesh. So your PSGs, in terms of thickness, I love using the PSG 2100, which just maintains a slab about 6 inches, and it'll finish with your concrete and the mortar that's underneath, the structural mortar that's underneath. It'll finish about 8 3/4. And this will have like 50 pounds per square foot of self-weight, okay? And then so on, you can see on this table, all the way down to a PSG 240. See that, which runs on a wire about 11 inches, and it'll finish with a slab about 14 inches. Okay, and then your weight is going to go up, right? But again, with a PSG 6, you have an R value, let's say about 36 versus PSG 2 will have an R value about RG2 100 will have an R value about 14. So that's the difference there. And then if you're a designer and we also have these tables handy there where you can go in, let's say with your PSG 2 100, and you want to see how far you want to go in having walls, let's say 50 feet, let's say in between 18 feet. So you still have a load about 50 pounds per square foot there. But let's say you want to go all the way down to 32, and then you can go down to the PSG 6 240, and then that's where you get the 60 pounds per square foot. So the longest we can go with these panels is 32 feet without any reinforcement in between, let's say beams or any beams in between those two walls. So that's how you use these tables here. So the applicable, let's say, codes with this system, right? We comply with the International Building Code, Residential Code, the Florida Building Code as well, the Puerto Rico Building Code. So we also comply with ESCE 7, right, for minimum design loads. So we have done our homework in terms of lab testing these on site. Now I want to show you some of the testings that we have done. It also complies with ICC standard design construction for storm shelters, which is very important, and also for the test 201, which this is also called in for Miami-Dade for high velocity winds there. So these panels can be used, let's say, in very cold areas like Antarctica, right? This project was a base there, and they needed to finish most of these buildings in 3 months. So that's how quick you can build these, But again, you have to now also have people and have a good schedule to do that. And you can also be like in Africa, where it's or right now in the States, where we have right now the high heat over hundreds, right? And then you can cool your buildings with these panels. There can be the difference of, let's say, of what's on the outside versus inside could be from 20 to 30 degrees, And this is how these panels work. Let's say you have a beam and you're projecting it to a regular concrete wall. So you'll have, let's say you start with 109 degrees. Then on the other side of that wall, if you touch it, it's going to be about almost 90 degrees, right? So that's a difference about 16 degrees. But with the structural insulated panels, let's say you have a core, let's say of 3 inches, you can start with that 109 degrees, but then you can see how that gradient starts lowering throughout that foam, and then comes out, let's say, almost 30 degrees less than what it has started, where the high beam or heat is. So it's very impressive. So again, you can provide an R value about 12 to 34 on walls, and an R value of 12 to 36 on roofs. And these are the R value for each of our panels. And let's say a PSM 80s will have an R value about 12, right? The U factor is 1 over the R. So that's what it is here on the next column there. So from let's say from 12, an R12, you can go all the way up to the PSG 240 with 36, with an R value of 36. And all that is in our manuals, and you can download that DRJ technical evaluation report from our website in GCT or Carmelo. So these are some of the testings we did to comply with the building code. So we did bending, compression, tension, to the full scale system. We built some rooms and did those testing there on that. So in our manual, we'll have the actual loads for these panels. So imagine a PSM 80 at let's say 8 feet, it'll have 15,500 pounds per linear foot, right? Okay, and if you go all the way down to the, let's say, either the PSM 240, but now it'll have that 15,000 pounds per linear foot all the way up to 20 feet. See that? So, and this is just for designers to calculate which type of panel you'll be using in these structures. And then we also have allowable transverse service loads for, let's say, for wind, right? And here you have, let's say, for wall height, let's say we're in 10 feet, so you have to go. This is all our value for a PSM 120. I'll have like 100 pounds per square feet. So we went to the lab and did all these testing, bending, flexural, and one of the most interesting is the lateral loads, where it has a responsive modification factor of 5. Regular buildings materials, it would be like 3, a little bit more higher, but ours was 5 plus 5.5, something like that. And so for Seismic, it's a great product to be in right now, and also for taking loads laterally as well. Then we also passed the task 201. This one, they project a 2x4 at 80 foot per second, and the way they pass or fail this test is that, well, if you hit one side of the wall and there's nothing coming out on the other side, then you pass it. In high velocity winds like hurricanes, I mean, you can see 2x4s pass block walls and other type of walls. So that's very important when we're building something, right? So this is our report from the Miami-Dade and also the Florida product approval, where we passed these tests with our system. And another important characteristic is that this system provides a level 3 of protection. And the way they test this is that they shoot it with a Magnum 44, and they put 3 rounds on the wall. And if let's say the bullets don't pass the other side, then it passes. So you can see there we passed this test as well. This would be great for FBI buildings and all other buildings where you want to be protected from bullets. So this is our technical evaluation report. This is how it looks, and this is equivalent to an ICCES report. And again, we have the dimensions, the R values, the capacities, and the reference tables that we just spoke, gave you some little bit of details on those as well. So the GRJ certification is our meet, let's say in 47 states, including Puerto Rico. And then if you have your structural engineer signs off in California, North Carolina, so you can also do buildings in those areas as well, which we have, with the structural concrete insulated panels. And you can get your approval with your your government agencies for, let's say, construction, or let's say use for get that permit, those permits. Okay, so basically a building with the structural concrete insulated panels, it will start like you see there in the left. Everybody will, all your neighbors will start saying, "What are you doing here? You're trying to build a house with foam and wire." And that's the way it looks. I mean, it looks like if you're in a cooler, okay? And but it'll start with a foundation, and we have some connections, steel wires, and we do a couple of reinforcement around the windows, U's, L's, and meshes, flat meshes. And then once we have placed all our, let's say, electricity conduits and the plumbing, and we have everything in place, then we shotcrete the walls with a structural mortar. At least we'll be having, let's say, 4,000 psi. So it'll look like a conventional concrete house. So the difference between a construction, let's say a conventional construction versus construction with a, let's say, structural concrete insulated panels, is that you don't need any big cranes to pick up steel forms or wooden forms. These panels are they only weigh like 1 pound a square foot, so they're easier to install. I mean, in 50 seconds you can install one panel, one next to each other. That's how quick you can do it. So this system is really fast in terms of labor and construction. So you'll need less people to work, less. You can also say almost less skilled people, because I think when you most need somebody to erect these is and finish it is when you're doing all the plastering. That's where you need somebody very good doing those finishing. But anybody can place them one next to each other, and then work them. So you'll have a cleaner, more safer environment, working environment when using these panels. And again, we're comparing here the traditional blocks versus, let's say, a wall with panels. When I speak to some contractors with 2 people, you can put, let's say, from 200 to 300 blocks a day. That's about 265 square feet. But with panels, we have installed from 1,000 to 2,000 square feet. That's almost 10 times faster when you're doing that. But again, you need a good construction schedule to do it quicker and faster. And here, let's see all kinds of projects we have gone through with the ACT panels and also Amadue as well. Here this is a school. They did the walls, and also the ceiling has insulation as well. And you can see here on the top here where they twist the panels to the side, and they use it as a beam. So every foot of this panel, it can either be a let's say a column or a beam, whichever you want to use it as. Here we integrated steel with the panels, right? They welded the rebars onto the steel, and they placed the panels and then the mortar. Okay. Here we have some buildings in Puerto Rico, houses made of concrete. More houses made of concrete. Right. So this is a single home from one of our architects who does a lot of SCIP designs for us. And here in 2020, there was a seismic event about, let's say, 6.4 near this building, and nothing. I mean, it was inspected and there was no cracks on whatsoever. And this has a cantilever about 10 feet, and everything is made with panels. This is a 6,000 square foot home in front of the beach. This was also in front of the beach. These kiosks were made in 2016, and we had a hurricane in Puerto Rico, where Maria, which came in 2017, and still they're there. I mean, intact. I mean, in that corner of the island, it was like it reached 200 miles per hour. So the versatility of using panels is that you can also bend them, right? You can make rounded shape. Okay, this is a Chili's restaurant where they used it on walls and also on the roof. And these are 18-foot walls. Okay? And then they sprayed the mortar on the exterior, interior. Oh, this is a an industrial Goya building, manufacturing. Use it on the walls as well. It's a nice house in Florida, real modern. This is another house in Florida we did with the panels. More projects there where they have combined wood and also the panels as well. So here you can see the columns and beams. As I say, you can build all your beams and columns with this material and also create shear walls as well. This one is also in Florida. And where we have our plant in Mississippi, this house is also all walls and roof slabs are in between slabs as well, are all panels. In Texas, Alabama, you can integrate as well steel. They did a steel porch on here. You can also do it with the panels. Probably the look that the architect wanted in that project. Okay, Los Angeles. Here are some international projects where there's a kindergarten, and what I loved the most about this picture was they didn't have any columns in the corner there, where you have this massive reinforcement on the walls with the steel, and a unique construction there. You can use them as curtain walls in hospitals. You can integrate steel girders and steel columns and beams. You can use the panels in the slabs, or as a curtain wall, or in between sections and walls inside, closing it. So you can go, real high, several story high buildings with these panels. Just the panels alone, if you were doing a building with just panels, you can go up to 4 floors, which I'm going to show you an example real soon here. There's another type of structure. Then you can see that you can make these panels rounded. Okay, and this is the project where we did all the panels from the first floor to the top, so that it's a 4-story high building, and everything is made out of panels. So it's a doable structure to just do it with just panels. And again, that's let's say that we call that the general information of these panels. And I'm gonna go, since we have a little bit more time, I'm going to spend the next session talking to you about some of the details we do when we're building these panels. And again, we start off with our technology, where it started in Italy and over 40 years ago. And the great part about this system is the R value. It lowers the heat or the cold inside that building, okay, depending on where you have your construction, okay. So, and our GCT has the Puerto Rico Building Code, Florida product approvals, so we can build these with the building code. We've done residential, commercial, industrial, as you've seen in those pictures. And the best thing is that no damages to construction after Hurricane Irma and Maria in any of the buildings we did in let's say in Puerto Rico. And it's a very durable system, that's especially on the beach or in the waterfront. So how do you start with building with this system? You start off with your foundation, right? And then you put your plastic sheeting, right? So no humidity or moisture is coming up from the ground. You put your rebar, right? So now you make your foundation, and it's not necessary you need to put all your dowels up from the bottom. I mean, you can drill them later on. So I prefer that, so that you can finish your floor easily without having all these rebars in the middle. The problem with putting these rebars from the bottom, from the base, right, is that they start twisting and turning, and then when you're going to put your panel, it's a little bit difficult. But the way we like to do is we drill a hole, let's say 7 inches down to the foundation or base, right? And then we leave 18 inches over the surface of the concrete, and all you need is number 3 rebar, 3/8 of an inch rebar. And that's how we have tested it with the technical evaluation report. If you want to go to a 1/2 inch, that's your decision. But with 3/8, it's enough. So you start in one side, let's say one side of the wall, you start at, let's say, at 0.0, and then every 16 inches, you drill a hole, right? And then on the other side, you're going to stagger it 8 inches from the first one, and then every 16 inches, then you space them out. So every inch you'll have a rebar on your wall. Okay, so let's say you have an in-between wall foundations. It's the same thing. Okay, so you drill your hole 7 inches down with your epoxy, and then if you're on the end of on the lateral sides of the building, then you have some sort of a foundation like this one. So you mark it, right, with a chalk line. You mark where you want to put your wall. Then you're going to drill the hole every 16 inches, like you see here. And again, you're better off doing it afterwards and after you finish your floor, because that way any mistakes of plumbing or you can move these wall 1 inch or 2 inches to the side, and it'll help you out. Now, if you start with your anchoring rebars from the bottom, then that's where it gets a little bit complicated when putting the panels. It won't be straight. So you take tie wire where your rebar is, and then you're gonna these rebar should go inside the panel, inside the mesh. Okay, so you can't see them outside the mesh. That's the way they were tested. So you start putting your first panel from one corner, and then let's say you want to finish a room, you just finish that room, okay? Or you can do the whole wall from one side to the other and cover a couple of rooms, but then you put one in between so you have this stiffness of this corner. That's the idea. So when you're out there, you have the wind, the sun on you, and the wind trying to move these panels. So that's why you want to start from a corner, and then tie it up to the next intersection, and then keep going. This is the way you do it. And the way we cut the wire, you can either use let's say a long plier, or you can use diamond disc, a grinder, right? And then that's how you cut the wire. To cut the foam, it's just regular, you use a regular saw and just cut it. Some people like cutting it on the floor. Some people like putting the whole panel on the wall and then marking where the window is going to be or the door, and then they cut it right there. And then these guys are very aggressive. They're carrying 3 panels at the same time. I urge you guys to just do it once at a time. It's real quick, so no need to put any hassle on the workers as well. But it's easier to do it one by one. Then you can do an assembly alignment like these where you want to fix the wall, making sure it's 90 degrees to the floor, right? So the idea is you put these wooden frames and you fix them to the floor, and then you start shooting mortar on the outside. And then once you finish shooting the mortar on the outside, then you take them out, and then you just spray the mortar inside. So they come in aluminum, or you can find them in wood. And the main thing is that to have that first let's say 2x4 on like probably 1.5 to 2 foot underneath the level of the roof, because on the top we're going to put an angle mesh on the top there, and it's very important to plumb these walls 90 degrees, so you'll use less mortar to finish off the walls. And then since these walls come with an overlap on one side, and then on the other side it'll come up with another overlap. So how do you join them is you keep joining them one next to the other. Then you're going to put a clip every 6 inches, and that's how you join them. And mainly you would use a 90 psi compressor with this machine on the right. That's the one we recommend because it's easier and faster. If you have 2 in your projects, it'll be much quicker. And these are our meshes, the L meshes, the U meshes, and these are your connections. And we also have meshes that are 4 feet by 4 feet. And we also have the flat meshes, which is about 15 inches to 4 feet, like that. And I'll show you in a minute where you use these. So if let's say you have the assembly of the floor with the wall, so you use 2 angle meshes there and fix those 2 walls together. And then if you have a joint like this here on the outside, this is where we use a 12 to a 15 inch mesh on this side there. And then if you have a building on the right here where you're going to put another wall on the top, so you put an angle mesh there, and then a flat mesh join the 3 panels, the slab panels and also the 2 wall panels. And this is our assembly for, let's say, reinforcing windows and doors, where you're going to put a U mesh all around the perimeter. Then you're going to take a flat mesh, which is about 1.5 feet by 4 feet. You cut those in 4 pieces. And this is the 4 pieces where you put them at 45 degrees. That way there's a movement or something that it won't crack on you on that 45-degree angle, you know. And usually what we do is we leave 2 inches on each side of a structural mortar so that when we put our frames or window frames, we have at least 2 inches where we can go with our Top Gun screw and align and fix those windows to the sides. So once you finish putting all your walls and then you put your panels on the roof, right? You start putting all your panels and fixing it, making sure that everything is level, right? Then we can also use on the roof these PSG that we spoke about, right? The PSGs, we do like a bond beam called where we have the rings, 3/8 of an inch rings, and then you space them out 6 to 8 inches, and then you have 1/2 inch rebar. You put 4 of them there, and so you'll create a beam. So in your girder, when the rebar is coming down, right, you'll finish with this bond beam there over the let's say the structural wall on the top. That's when using this type of panel. That's just an idea. Here's an example of that. This one has a cantilever about 4 feet. So they decided to put the bond beam here and to the right here as well. And then you also see negative rebar on the top every foot, probably 1/2 inch. That will help, you know, with that cantilever as well. You know, we have drawings as well. We can provide the designer, CAD and also PDF. Then when you're shoring it on the bottom, make sure that they're spaced out for every 4 feet before you get on top of this roof, right? But it's very important that the length of that panel, you'll have a perpendicular, you know, either 4x4 or 2x4 crossing it, so that, you know, it'll support, you know, what you're doing on the top, right? And also it'll support the weight as well. Okay, so it says, so you can see here the 2x4s. They already put, let's say, some electric there, and so what we do with the plumbing and electrics installation, so we buy ourselves a heat gun, which must be at least 1,000 Fahrenheit, right? And then you mark all your boxes and where you're going to put your conduits. Sometimes you don't need to cut these meshes if you use, let's say, flexible, you know, wiring tubings, you know. And here you can see how they use a 2x6 mold for the frame, and then when they spray the structural mortar, that you already have it ready for the walls and windows, okay, for that framing. So you can buy one of these heat guns, and you recess the, let's say, the boxes where your finishing is going to be. You do your plumbing, and wherever you break the let's say the mesh, you have to put a flat mesh over that. So you melt the surface of the foam, then you put the conduits. That's how you do it. Or either plumbing or electric, you do it the same way. So once you have everything put together, the angles, the meshes, the wiring, at least the plumbing and the electric conduits, then you're ready to apply mortar. And so what we do is we put guides every 3 feet or 4 feet. We put guides, let's say, a 1/2 inch pipe schedule 40, which has a exterior diameter of 3/4 inch, because we want over the mesh 3/4 of an inch of a structural mortar. Okay, so you start from left to right and start spraying from bottom to top, right? So you put your pipes, okay, and you can use tie wires there, and to do that, so you start spraying from the bottom, and then when you have like 15 minutes to take out the first guide, right? So you take a knife and cut the tie wrap. Okay, so you screed the mortar, and then after you screed it, then you're going to make lines from left to right, so you have a mechanical bond on your, let's say, walls and also on your ceiling. Because if you, let's say, you want to spray an additional coat of finishing product mortar, like 3/8 of an inch, then you would do that. If you're using, let's say, a synthetic stucco, which is your spraying, then you can leave your structural mortar flat and do that. It all depends. So here's a video of how that looks. See the framing already on the windows? That will ease up a lot of work trying to put that straight there and then put your windows. And on the ceiling, we do it in 3 passes. We do a light pass first with the structural mortar, then up to the mesh, and then we put the guides over the mesh, and that would be your third pass of structural mortar. Everything you see, it's they use duct tape to make sure the boxes don't get dirty. You can see there the guide, the PVC pipe guide there. So let's leave it there. So I don't know if you have any questions or right now of what we discussed. We're open to questions right now.
Yeah, hi. I coming from a background of farming and casting. I was wondering if it's possible to use the EPS in the center of a farm work and cast the concrete on both sides. It seems like it would be quicker to finish that way than the shotcrete. Is that possible?
Well, we've done precast elements. You can do it, outside and then they bring them to the site, and there's a factory in Texas that does that. We saw them the panels, and they cast in their site. They cast the walls, and they just bring them in. I might have not understood what you wanted to do.
I'm actually talking about cast in place.
Okay.
You erect the walls first, standard way that you showed us, and then you form around those walls. And then you cast with, say, P grade concrete mix. Is that possible? Because I want to use it as a curtain wall, and I have to cast the columns and the beams.
Okay.
So if I could cast everything one time.
Yep.
Yeah. So Ismail, I'd like to tune in here to.
Yeah, go ahead, Scott.
That's certainly possible, and it's done a lot. I know that one of the longtime designers out of Argentina, they do quite a bit of it. I would say that it's best suited for multiple building projects. There is an investment into the forms, so you have to run those numbers, and if it's available for rent and all of that, that's all good. But it certainly is. What is typically done is when we're spraying, we're code compliant with 3/4 inch coverage. If you're going to grout and cast in place, you're typically opening it up a little bit more to be able to pump and grout easier.
Yeah, you're probably going to be 2 inches on each side at least.
That's about right. That's about what's typical. And if you get a hold of us, I can share some further information about that. Okay.
How can we get a hold of you guys?
My email is on our website. My name's Scott Miller. So smiller@gctm2.com.
Thank you very much.
You're welcome.
Hey Scott, this is Robbie. I had a question for you. Can you guys do an integral color when you're applying that finish mortar on the exterior? Like if you wanted more of a white finish, can you just go ahead and integrate color?
You sure can. We do have finish mortars that are colorized. It's you really need to look at your water content and be very, very, very consistent to be as consistent in color as well. So yes, that can be done. A lot of times it might be, I'm not trying to not sell you finished mortar and things like that, but sometimes it can make sense too to colorize and seal with another finishing product. If you colorize the mortar as a finishing mortar, you still are probably most likely going to seal it as well. Anyway, clear sealer or what have you.
Thank you. That makes sense.
Hey, one question: is there a cost comparison sheet, something that we can look into?
Okay, I'll weigh in if Ismail. The way I'd like to frame that is to let you work some numbers, and we can look at different projects, or I have a sample projects, and we can chew on that to have you understand, what it takes. And there's lots of considerations. I have an Excel file that I use that you can use. It'll put it in terms of man hours for you. And
okay.
Sometimes, if you can reach out to me again, my email is smiller@gctm2.com. We can look at a typical project, and I can help you understand what it takes and try to get you comfortable with you know, the man hours it might require.
Sounds good.
Yep, and then by that, you know, there's other considerations too that you need to. But I usually frame a cost analysis with what I call a gray shell price, and we can break that all down. If you reach out to me, we'll pick it up from there.
Thank you.
You're welcome. One more. Okay, Ismail.
I got lost there in technology for a minute. Just got back. Yeah. Any other question, guys? At least Scott was helping you guys out.
Hello.
We're good. Yeah, I can hear you, Rob.
Okay. Yeah, I got on late. Are you guys going to be making a YouTube so I can watch the whole? I had technical difficulties to get on to 5 minutes ago. So. Sure.
Yeah, we'll probably save that on YouTube, and you can go in and see it anytime you want. Yeah.
Okay. Yeah. The other question I had was, I'm in Canada here, but like, what do you guys have anybody in Canada that sells your mortar mix? You got to have that mortar mix so it sticks to the ceiling and the walls properly, right?
Mm-hmm. Well, we have other alternatives as well. You can use other mortars. Since we make these mortars in Mississippi, but sometimes it's hard to get them all the way down to say either Florida or let's say Canada. So we can joint venture with somebody and have some of our, let's say, design mixes with some local, let's say, a company as well. Yeah, like we're doing right now in Florida.
Yeah, I been doing some research on the concrete side of things, and I found a new additive on the market that makes the concrete almost 100% water.
Mm-hmm.
And I mean, these guys are claiming you don't need, like, if I do use your technology below grade, I don't need dimple mats or anything. They're not worried about any kind of leaks. Or I would just do that, just a belt and suspender kind of thing. Why not add some protection, right, below grade? But also, they're saying even for the roof, you don't need any finishing or any waterproofing on top of that. So how does it affect your mix? Like, you got to take the additive into. I guess the guy would have to try some, mix it with it, see how it went on. I would imagine.
So, Rob, Scott Miller here. I have been to Canada Water, I think it was called. And we did quite a big project. It was curtain walls mostly for a high rise. And do you have to use our mix? No, you don't have to use our mortars. The only specification you have to use is that whatever is sprayed or cast in place on the walls need to be 4,000 psi. On the top, as concrete, it's a minimum 3,500 psi concrete as the top of the slab. We found on that project that they like to use our mortars overhead, so on the ceiling side, which it kind of worked pretty well as far as the ratio of panel to mortar accommodated everything. And then sealant-wise, whether that's after, I don't. If you said it's an integrated integral mix, that would
be. Yeah, it's an add mix. Yeah, you add it while you're mixing the concrete.
Yeah, with the MTech machinery and our pre-blended bags, that would be a little bit. That would be difficult to do. But we're always receptive to tweaking. If we do have a facility to experiment and try things. Do you know if that's liquid or dry? That sounds liquid.
I think it is. We can get it either way, liquid or dry.
Yeah. So as a dry product, it can be pre-mixed with our, if we wanted to tweak. And but that's a little bit of a process. That's not something that we could do immediately.
Oh, I get it. Yeah. But I'm just thinking that would be a pretty good thing if you could have a waterproof roof and side. Even if I would still put shingles on it, and I would still put, tar and dimple mat on the below grade stuff. So, yeah, those are just a couple of the questions I had. I guess I got to get a hold of you when I get a little bit more serious. I'm still doing lots of research because it's not like building in Mississippi. It's like last year we had minus 50 degrees. And if
Yeah.
you've got a crack and it's got water in it, it's going to happen.
Oh, yes. I always was aware of cold weather, but I was there in December. I'm from Florida, and it was a stark reality, and we had to use heat cannons and curtain off the work.
Hoarding.
And all
Yeah,
of that.
hoarding. Yeah.
Yeah.
Yeah, just make
Okay.
sure it doesn't rain that day.
Yeah, right. If it does, it's ice. It doesn't matter.
Yeah.
Okay, well, that's all I had. I guess I'll wait for the video and see what you guys got going there, and maybe reach out here when I got more information about the ad mixture. So,
Sure. Good.
all right, thanks for your time, guys. Appreciate it. Go
Okay,
show
Rob.
what I did here.
Great,
So,
great having you. Anybody else have a question?
I had a quick question. I think Scott's familiar with the plan that we're working on. I was just curious if you're doing like a 2 or 3 building, in your guys' experience, does it make more sense to do like one long skip panel on the walls and then attach in your floors to that? Or does it make more sense to do like 2 or 3 layers of like 10 or 11 foot wall panels and stack them on top of each other? Do you guys have a recommended methodology for that?
Yeah, shorter is better in this case. Yeah. So I would stack them instead of having a longer one, and have let's say beams in between as well, which helps out more. Yeah.
Thank you.
actually, I got a question again. This is Canada.
Uh-huh.
That guy piqued my interest. Like, when you are doing a ceiling, obviously that's going to make that panel droop. Are you guys putting any kind of pre-stress into the panel above so that when you release it, it's level? Like, are you using posts to hold it up a little bit past the straight?
You have to support it every 4 feet. With a 4x4, 2x4, and again perpendicular to the length of those panels.
Yeah.
That's a must. I mean, that way you don't have any sags in between the panels. When you're you have to pour let's say spray the structural mortar underneath first, and that'll be like a form, right? Then when you pour your concrete on the top, right, on the top of that roof slab, then now you're supported, and plus now you have like a form of let's say at least an inch and a half of structural concrete underneath, and that'll help out a lot.
So what I'm saying is, do you put any kind of pre-bend in there with the purlins?
Rob, with your shoring, you can camber the roof to a little past what a typical camber might want. So you adjust your shoring if that's what you're asking.
Yeah.
We also have beam panels with beam pockets, and you can also camber the integral. There's typically 2 number 4s that run in those, and those can also be slightly cambered if you like.
What is it? Cambering about on average, say ½ inch or something like that, or?
It depends on the span. So half the span times 16ths or 30 seconds, right, in feet. Ismail, you want to back me up on that, camber wise?
If it's a slopey roof, or
yeah, well, camber, typically your engineer might spec that, and for different loads and different scenarios, it might be different. But if you had a 20-foot span, you're really looking at 10 feet times whether it's a 32nd or a 16th, per. So 10 16ths,
Okay, got it.
10
So
32nd.
less than an inch.
Yeah, and you because you don't want to, you can go too much. If you think about that and you camber, you're actually making a hump on the top side. With the concrete that's cast in place on top, you need 2 inches so coverage. So if you put extra camber, you're taking away from that 2 inches. So you might need to add a little more on the top side.
Yeah. Well, wouldn't you have to put a camber when you're pouring the top side too, so that when you release, everything's going to be level top and bottom?
Excuse me. Yeah, that can be done. So most of that, and I'll let Ismail kind of tone in here a little bit from the engineer side. But the wet set is, that's going to be your heaviest with guys working, and it's wet and what have you. some of that, you have sort of an initial set, and it's a small amount, and all of that, the last is long-term deflection. What time?
Yeah. One other thing I'd like to do is, I know that you guys are putting electrical and plumbing in these panels and then casting the concrete over top. What about if a guy was to put also HVAC in these panels? Does that matter? I don't think it would matter, because I'm just going to remove the styrofoam, not any structural part, right?
Scott, you want to chime in on that one?
Yeah.
On the HVAC part?
Yeah, depending on how what you're going to run, there's not a lot of room in the, our thickest panels might finish out as floor slabs, might finish out at 14 1/4. I think I really like when the designer designs chases and drops in some areas for that. Can it be done? Yeah. There's airwise, there's micro ducts these days. There's a lot of people use ductless mini splits, mostly in the South. But if you either drop ceilings or kind of plan chases for larger mechanicals, it's a good idea.
Well, these aren't larger. I'm planning on running the ERV. I'm not using it for heat, because my heat will be in my slab. In the ceiling, I want to run the ERV system, which is I think 3 3/4 OD tooth pipe, plastic pipe, so of course I could probably go even smaller if I had to.
I don't know the acronym. Are you talking about thermal, just running pipe in hot water and cool water and thermal radiant?
No, it's you know what an HRV is?
Yeah, I got to show my ignorance and tell you no.
Okay, well, it's a heat recovery, and so heat recovery, so because you used to change the air in your house 2 or 3 times per hour.
Right.
And the problem with that in Canada anyways, if you're pumping in -30 weather, right, you're going to spend a lot on your heating bill. So what they do is the air that is going out heats the air coming in. So it's a heat exchange.
Yeah.
So the ERV was developed for your country because it not only exchanges the heat, but it also exchanges the moisture. And now they've made them good for Canada's climate. So now you can maintain, because obviously if you're pumping in -30 air, it's very high and you'll have to dry your house out. Once you maintain a humidity level you like, it will actually exchange the humidity into the incoming air and the temperature. And they're about 95% efficient right now, so it's pretty good stuff. But anyways, those pipes, you have to pretty well have a pipe running to each room, and they are about 3 3/4 inches.
Yeah, that's a totally doable. Yeah. That's very doable, especially in our thicker panels. That's an easy thing.
I figured it wouldn't be.
Yeah, you'd have to pay attention to, if it's our beam panels like the PSG that has the concrete beams in it, you'd want to run parallel wherever you wouldn't want, not that you couldn't, but you'd want to avoid crossing those, right?
Yeah, got it. Okay, yeah, I was pretty sure a guy could do that, but I thought he wouldn't hurt to ask.
Yeah.
So, now you better get ERVs down in your house. Okay,
well, I kind of knew of that. I kind of knew of that, but that's I would say that's not my particulars.
Yeah.
Okay.
Okay, that's it for me. Thanks, guys.
You're welcome, Rob.
All right, guys. So if you guys have any other questions, you can either email us or call us. I left our phone numbers. You can also address to info@carmelo.com or you go to the TCT website as well, and there we have our phones, and you can ask us any other questions. Okay.
Okay. Thank you all. Thank you, Ismail.
All right. Thank you, guys. Thank you, Scott. And thank you for all your questions. And